Hi guys, sorry about that. Sorry about Mr. Russell's buffoonery to start off. Good evening. So we're going to do some crossover and higher stuff now for a little bit. We've got a few requests from the last hour that we're going to start off with, but before that, I'm just going to quickly re-go over how to reset that calculator. I know Miss Milner did this before. Children, please. I know we went through that before with Miss Milner, but it's very, very important because some people like to ruin their calculators when they leave the room. So if your calculator, for example, does not have that little D in the top or the math in the top there, it will not work properly. And especially when you do trigonometry, it will give you the wrong answer. So first thing we should do when we get into that room is reset that calculator, and I'm sure we'll be reminded of this in the morning as well. So what we're looking for now then is that little CLR in yellow. That means clear. So to get that, we're going to press Shift and the clear button. That will bring you up some options. Safest bet, just press 3 to get rid of everything. So press 3, equals is yes, and then AC goes back to the start. And that will solve any problems you have, including the one where people think it's funny to change the darkness to make it so you can't see the numbers. Okay? So to start off with now, then we're going to look at some angles in parallel lines. So can we see that okay, sir?
Yeah, everything's good.
Brilliant. Okay, so here I've got a question. It's a bit of a tricky one. This is quite easily could come up on foundation or higher. So whoever is watching this, it will be important. So we're trying to find that.
20 viewers.
That is what we are looking for in the end. So I'm going to work out all the bits I can first to begin with. Now, the important parts about this are these lines here. That tells us that these three are all parallel. So we need to think about our angles in parallel lines. So think about that. We've got this parallel line along here and this one along here, and they are split with this line in the middle. Now, because we know that that is 38 degrees, that means that must also be 38 degrees because they are on opposite sides of the line. They are alternate angles. Don't try and name them as a letter because that will get you no marks. They are alternate. They're on alternate sides of that line. And alternate angles are equal. If it says you must give reasons, you must use that word equal. You must use that word alternate. Okay? We also know then, at the top, we've also got two parallel lines and another line that cuts those like that. So once again, that's 38. That bit there is on the other side of the line. That is also 38 degrees because they are alternate. Once again, you need to say alternate, you need to say equal. Without that, you are not getting full marks. The next important point then is these lines here. That means all of those lines are exactly the same length. And if they're exactly the same length, then that at the top there is an isosceles triangle. And in an isosceles triangle, base angles are also equal. Once again, I'm underlining the key words you need to say for each bit.
We have a question, sir.
Go for it.
If it does not tell us they are parallel, do we assume they are not, even if they look parallel?
I would say correct, yes. If they are parallel lines, there will be something, it will either tell you they're parallel or it will give you some sort of excuse for that. It will give you some way to work out that they are parallel. Okay, so we know that these base angles are equal because it is an isosceles triangle, so that is also 38 degrees. Once again, that angle is the same as that angle, so that is also 38 degrees. We can now work out then these two angles here because we've got two angles in a triangle, and we also know that angles in a triangle add to 180 degrees, or sum to 180 degrees. Once again, the things I'm underlining there, you need to put in order to get full marks. So if I did 38, add 38, and now I'm just going to double check because I don't trust myself, I'm going to use my calculator. 38, add 38 equals 76. 180, take away 76 is, once again, I'm going to double check absolutely everything, guys, because it's not worth getting that wrong, is 104 degrees. So that's 104 degrees. We should have noticed by now that these two triangles are the same, so that is also 104 degrees, which leaves us with this part round here. The last reason you need to give are angles around a point are 360 degrees. So around a point, 360 degrees. So 104 add 104 equals 208. So 360 take away 208. Once again, double check. It would be embarrassing to get this wrong on air. 152 degrees. Yes, sir.
Question from Fraser. Is that alternate that you've written down, sir?
It is alternate, yes, Fraser.
Yes.
Okay.
I think we're just viewing your handwriting.
Apologies. I thought that was quite neat as well. Okay, now another request that we had earlier. We've got some solving simultaneous equations. Comes up every year, and I'm sure it will come up again. So in order to do this, we need to get it so that either our numbers in front of our x's are the same, or our numbers in front of our y's are the same. Now, it really doesn't matter which way you do it. Going to go to make the x's the same. So I want to see what number do 2 and 3 both go into. Well, they both go into 6. So I'm going to multiply this top one by 3 and this bottom one by 2. So I'm just label that number 1 and number 2 so you know which equation I'm on about. So if we multiply number 1 by 3, that will give us 2x times 3 is 6x. Subtract 4 times 3 is 12y. And that equals 19 times 3. Once again, if you're not sure, double check. Don't make a silly mistake. It's 57. Now, underneath that, equation 2 multiplied by 2. So we've got 6x plus 10y equals 2. I've now got the same number in front of both of my x's. Now, it's important to have a look at these now and see if they have the same sign. Now, these are both positive 6x. So in order to get rid of those, I'm going to do one of my equations, take away the other. Now, it doesn't matter which way you do it, it will always simplify in the end. Okay, I'm going to label this one number 3 and this one 4. Okay, I'm going to do number 3, take away number 4, just to see what happens. If you don't like doing that way, you can do it the other way. So 6, take away 6, disappears. Then we've got, I'm just going to write it up here to make sure we can see, minus 12, subtract 10. So that would be negative 22. Now, I know some people struggle with negative numbers. Write it down, put it in your calculator to double check. Negative 12 subtract 10 is negative 22. So I've got negative 22y equals 57 take away 2 is 55. This isn't a nice one, is it? Now, I don't like negative 22. Why? So I'm going to change that into a positive. So I'm going to multiply by minus 1 to get 22y equals, and because I've changed that from negative to positive, that would need to go to positive to negative. So that equals minus 55. So y would equal minus 55 divided by 22, which is minus 5 over 2. And you can just leave it like that. It's a calculator paper, so if you wanted to, you could also put it as minus 2.5. Okay, not done just yet though. I need to work out what x is. So I'm going to substitute now into, and I'm going to pick equation 2. Just because there's no negatives in it, it looks nicer. So if I write this in this bottom corner here, sorry, am I still on the page there, sir?
Yep.
So I've got 3x plus 5 lots of negative 2.5 equals 1. Okay, so we've got 3x, 5 times minus 2.5 is minus 12.5, and that equals 1. Okay, to solve this then, add 12.5, so 3x equals 13.5, divide it by 3, divide it by 3. So 13.5 divided by 3 is 9 over 2, or if you prefer a decimal, press your S to D button, and that is 4.5. Make it very clear, so y is minus 2.5, x is 4.5. It's okay, it is a calculator paper. They could throw you some nasty numbers. Just follow the methods that you already know well. 1 second while I go and grab another question. We are now going to work through a bit of trigonometry. Okay, so we're just going to go with the basic skills.
Thank you to Mr. Preston for keeping us supplied.
I'm just going to go through a few of the basic skills which you can then apply to your more problem-solving questions. So, first thing, I'm going to have a look here. I need to think. Is that a right-angled triangle? It is. So what I'm going to be finding is either using Pythagoras or using trigonometry. So now I need to decide which one I'm going to use. Well, the big clue here is we've got an angle there. Okay, if I've got an angle, then it must be trigonometry. So it's a right angle triangle. I'm using trigonometry. I'm going to use, what is it, sir?
SOHCAHTOA.
Thank you. So I'm going to label each side. Now, the hypotenuse is always the longest side. It is always opposite your right angle. So that is your hypotenuse. That then is your opposite because it is opposite the angle we are given. And then that is the adjacent. So now what am I trying to find out? It says the length of the side RT. Well, remember, RT just means the line that goes from R to T. So that one along there. I'm just going to give it a letter. I'm going to call it X, just so I've got something to refer to it as. So now, I know I'm going to do something to do with that side. I also know I'm given that side. I don't know anything about the hypotenuse. I'm going to ignore it. So I need to look which one of my SOHCAHTOAs has
SOHCAHTOA.
has O and A in it. It is going to be my tangent. Okay, so for those of us that like the triangles, we've got T, O, and A like that. We are trying to find this time the adjacent, so I'm going to cover up my adjacent. So my X would be my opposite, which is 14, divided by, remember T means tan, of my angle there, so 53. Put that straight into your calculator, so 14 over tan 53 is 10.5 to 1 decimal place. Okay, and that is okay to leave it like that. It sometimes tells you what to give it as. Now then, this one, once again, we have got a right angle triangle. We haven't been given an angle this time, but it says we need to find an angle. You cannot find a missing angle using Pythagoras. So we know it's got to be trigonometry again. Mr. Russell's dying to do it again. Go on, sir.
SOHCAHTOA.
Thank you. So once again, I'm going to label my sides. Now this time I haven't got an angle, but it does say ACB. So remember, that's the angle from A to C to B. So it's that one there I'm looking at. And I'm going to give that the posh Greek letter theta there. That's just the letter we give to missing angles. Put whatever you want. Put a question mark there if you want to. Okay, so once again, same thing I do every time. I'm going to label my sides. So that is opposite my angle. That is opposite my right angle, so it's a hypotenuse. And then that leaves that as the adjacent. I'm going to circle, who's giving me abuse, sir?
George is actually feeling sorry for you. I'm presuming it's due to SOHCAHTOA.
Okay, so I've circled the sides I want. So once again, adjacent this time is useless to us. So which one has O and H in? It is our SOH. So well, this time we want to find our missing angle. So that's the sine. So we know that sine of our angle is equal to opposite, which is 8, divided by the hypotenuse, which is 10.5. So if we work out what that is then, 8 divided by 10.5 is 16 over 21. I think someone wants me to leave. Turn the lights off.
Guys,
16 over 21. If you prefer it as a decimal, it would be 0.761904, and that is all recurring. Okay, I would strongly suggest if you write in the decimal, then write the whole thing down, just so you get in your full marks. Now, this is where people normally go wrong. That is not your final answer. That does not look like 0.761904 recurring degrees. Okay, this is the important bit. Now we need to get rid of it. Now to get rid of that, we do the opposite of our sine. So to do that, we're looking for the thing that says sine to -1, and to do that we press shift and sine. So shift, sine, and then put in your answer from before. So it was 16 over 21, and then equals will be 49.6 degrees to 1 decimal place. Okay, thank you. Now we're moving on to one that is exclusively for hire. So if there's any foundation people still listening, you can switch your ears off. First thing I'm looking at here, I've got another triangle. It is not right angled. So that means Mr. Russell's not got an excuse to say it again because we could not use SOHCAHTOA. So we now need to look. We've got two things we could use. We have got the sine rule, or we've got the cosine rule. Now, the first thing we're going to check is, can we do the sine rule? To do that, we need to see, have we got a side and the opposite angle to that side? Well, we know that angle, we know that angle, and we know that side. So we know that that side and that side are opposites. We have them both, so yes, we can use the sine rule, which is a lot easier than the cosine rule if you can use it. So the sine rule comes in two forms. It either looks like this, so A over sine A equals B over sine B equals C over sine C. We are going to use that one if we've got a missing side. If we've got a missing angle that we're trying to find, we're just going to flip it and do it the other way. So sine A over A equals sine B over B equals sine C over C. Now, I know a lot of people from my groups actually use this instead of SOHCAHTOA as well because they prefer to use it. That's absolutely fine. If you want to do that, it still works. So I'm just writing that is missing angle. Okay, now in order to do this, we're going to have to label our things a little bit different. Now, this has kindly already labelled them A, B, and C for us. Now, you can change those if you want to, cross them out, put your own ones in, whatever works best for you. Now, the important part about labelling this, though, is that the angles are given capital letters. The sides opposite them are given the same letter, but lowercase. So that's A, that one will be A. That's B, that one will be little b. That's C, so this side will be little c. So once again, this time we are trying to find the length BC. So if we're trying to find a missing length or missing side, we're going to use this cosine rule. Okay, so we're trying to find A, so we need A and sine A. And we're given B and B, so we're going to use those. Now we don't know anything about C, so we're just going to ignore that. We only need two of those in order to make this work. So we have got A over sine A equals B over sine B. I'm just now going to substitute in my values. So A, I don't know, that's what I'm trying to find. So it'll be A over sine of A is 33. And that equals little b, which was 15, over sine big B is 112. Now I'm just going to do a little bit of rearranging here. That's A divided by sine 33, and I don't want that, I just want A. So I'm going to multiply both sides by sine 33. So A equals 15 over sine 112 times sine 33. Put that straight into your calculator exactly how it is. Remember that fraction button, it is a lifesaver. 15 over sine 112 times sine 33 equals, and that will tell you straight away it is 8.81118182. I would write that out in full for the first time, then on your answer line, 8.8 is fine to 1 decimal place. Thank you. Just going to rest my voice for a second. Mr. Russell, you're on air.
Thank you very much. Huh? Yep. Good evening. Right, I'm taking over for a bit while Mr. Sanders rests his voice. I'm starting off with an error interval. So Jim's rounded his number, he's got to 1 decimal place and his result is 7.2. There's several different ways of looking at this one. I would start by thinking on a number line. If 7.2 was the number it was rounded to, if it's been rounded to 1 decimal place, I tend to think of counting up and down on those 1 decimal places. So the options that this number had, it could have gone to 7.1, 7.2 or 7.3. So if we then think about the numbers that would have definitely gone to that 7.2, well, it's going to be halfway between each. So halfway between 7.1 and 7.2 would be 7.15. And we have 7.25 here. If we are writing it as an error interval, don't be put off just by the words that they use. What they are wanting you to use is the number x between 7.15 and 7.25. And it's when they're mentioning error interval, that's the use of inequality symbols. Well, we know it can be equal to 7.15, so we know the 5 will round up to that 2. So that allows us to use the inequality symbol with an equal sign. But 7.25 would go to 7.3, so therefore we can only use the x is less than 7.25, where it's x is greater than 7.15. Okay, that's one down. And I feel like changing colour pen every time. Why not keep it a little bit lively? What have we got next? I'm going to go for this one. Okay. Fairly new topic to GCSE on the 9-1 spec. This is expanding triple brackets. So my preference on this one is to not worry about the fact it's triple brackets and look at them as a pair of two brackets that will change into a single bracket and then expand that with another bracket. So at the moment I've put square brackets around my first two. I could have done it around the last two, but I've just chosen the first two because it comes first. What I'm doing here then, I'm wanting to expand. You've got probably several different methods. You might use foil, you might use a smiley face, you might use the crab, the claw, whatever you like. I'm just going to go for foil. So I'm going to go for first, so that's 2x multiplied by 2x will give me, I'll keep it inside my square brackets for now, that's 4x. I'm going to use 2x with a negative 5, which will give me minus 10x. I'll then use my plus 5 with a 2x, which will give me a positive 10x. That's convenient. And the plus 5 with the negative 5 will give me a negative 25 and not 0. We don't add, we always multiply. So that's the square brackets sorted. I must remember I'm still multiplying that by 3x plus 7. Okay. If I simplified this, that should have been 4x squared. I've just realised that was a 2x multiplied by 2, it should have been 4x squared. If I simplify this square bracket down, I will get 4x squared. The minus 10x and the plus 10x, this part here is going to cancel out. They're going to completely go, so I'll get left with a minus 25. And I'm multiplying that by the 3x plus 7. So it's just a case then of repeating the process. This one, thankfully, is a lot more straightforward than some others that you might get. You might end up with an extra term in the middle. So we've got 4x squared multiplied by 3x. That will give me 12 from the 4 times the 3 and an x cubed from x squared times by x. So that's these two sorted. I'll use the 4x again, 4x squared, sorry, this time with a 7. That's going to give me 28x squared. I'm then going to use a negative 25 with my 3x, so it'll be a negative 75x. And I'm going to use a negative 25 with the positive 7. It's a calculator paper, why not use it? Negative 25 multiplied by 7, it gives me negative 175. Okay, it's there for a use. The numbers aren't massive, but you can always use it. Just checking my answer. I've got an x cubed, an x squared, an x, and a constant, a number. I cannot simplify any of that any further than what it is right now. So that there is my answer to that one. Okay. What have we got next? Okay, solve. If they say solve, they're wanting you to give an answer to x. Right, okay, sorry, that's just me talking with whispers, which you probably heard, to Mr. Sanders. Okay, solve. I'm wanting to find answers for x. Looking at this initially, the fact that it's equal to 0 means that I can do several different things with it. I could, if I wanted, use a quadratic formula on here, or I could factorise if it does. Well, if I'm trying to factorise it, I'm wanting numbers that multiply together to give a negative 24, whilst I add together to give a positive 10. Well, numbers that multiply to get 24 and add to get 10. Let's think we could have negative 6 and negative 4. They multiply, but they multiply together to give sorry, they multiply together to give a positive 24. If we change one of them to a plus, that would, if we multiply those together, we get minus 24, but they add together to get a negative 2. This doesn't look like it's going to work if we try using factorising. So therefore, let's think it could well be using the quadratic formula. Now, the quadratic formula you're not given anymore. So, to those that have cast it to your memory, well done. X equals minus b plus or minus the square root of b squared minus 4ac, all of which is divided by 2a. Now, it's a case of remembering which parts are a, b, and c. Well, a is the number in front of your x squared. So, in this case, I'll put it here, a is 1. We have an imaginary 1 if you're not sure. B is a number in front of just your x's, in which case it's 10. And C, in this case, is the constant, the number by itself, is negative 24. Then it's a case of applying these three numbers into your formula. So we're going to start with x equaling minus 10 plus or minus the square root of b squared. So b squared, that is 100, minus, I will put this in brackets, 4 multiplied by 1 multiplied by a negative 24, all of which is being divided by 2 lots of a, which is just 2. We have a calculator, so we may as well use it. I'm going to sort out my square root first. So I've got minus 10 plus or minus the square root of, well, it's 100 minus, you see I can type, I'm writing my brackets in as well. 4 multiplied by 1 multiplied by a negative 24 gives me 196. That's convenient. Divided by 2. Okay, so we must remember we're doing the square root of 196. The square root of 196. Just checking on here, we can use a calculator even though we know it's 14. So I've got negative 10 plus or minus 14 divided by 2. Okay, so if I choose one option, I've got negative 10 add 14 divided by 2, or I've got negative 10 subtract 14 divided by 2. So negative 10 plus 14 gives me 4 divided by 2, so I will have one option as 4 divided by 2 gives me 2. Oh, the numbers were 10 and 12, weren't they? Flipping heck. Oh, negative 10 minus 14 is minus 24. Divide that by 2, you get x equaling minus 12. Oh, what joys. That would have been a lot easier had I realised I could have used other options right from the beginning. Never mind. I still got the right answers. X equals 2 or x equals minus 12. 12. Fantastic. We got any comments there, or did they all realise I could have done that a lot quicker?
You said just bang in the formula.
Bang it in the formula?
Yeah.
Every time, why not? Well, this one, the fact that it tells me use the solutions correct to 3 significant figures is a massive indicator I will be using the quadratic formula. If it's 3 significant figures, it's very unlikely to be factorising. So again, just a reminder, x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's go. We know that a is 1. B is minus 5 this time. We've got a minus 5. And C is worth 3. So we will bang it in the formula as whoever said that. We've got 5 plus or minus the square root of a minus 5 squared minus 4 lots of 1, lots of 3. All of which will be divided by 2 lots of 1, which is just 2. So 5 plus or minus the square root of, bringing the calculator back into play. Minus 5 squared, there's several options to do it on the calculator. I'm going to go for brackets minus 5 squared. No, why is it showing as minus 25? I didn't close my brackets off, that's why. Brackets minus 5 squared, there we go. Proving it's positive. We can have 25 there. Minus 4 lots of 1 lots of 3 is 12. All divided by 2. So I'm going to have, therefore, 5 plus or minus the square root of 13 divided by 2. Now, it's at this point that it's key. We need to keep it to 3 significant figures, but we'll keep as much on the display as possible. So I'm going to go for, I'm typing in as a fraction, 5 plus the square root of 13 divided by 2. You can see I've got it all on the screen there. Is that showing up all right, sir? Can we see that?
Raise it a little bit.
Okay. So I've typed it all in as a fraction using the fraction button and the square root button there. 5 plus square root of 13 divided by 2. It proves that I've typed it in right, and then it's just a case of pressing the SD button, surge to decimal. That comes out at 4.302777, etc. So 3 significant figures on that gives it to 4.30. I will do the alternate, so I'm going to go back in there, and I'm just deleting that and putting a minus sign in place. Shows it there, SD again. This time it's giving me 0.69722, etc. So to 3 significant figures, 0.697. Although I had 3 numbers here, I include the 0 because that 2's not changed. I need to show that I was using 3 numbers. I'm not using the 0. It's not significant until it becomes trapped. 6, 9, and 7 are my 3 significant figures there. Okay, right. Next. Okay, just confirm that when I was whispering with Mr. Sanders earlier, it was, would this appear on a calculator? It's more than likely that this one may say, show that 0.78, both parts recurring, is whatever our answer is, as a fraction. Down a bit. Better? There we go. Okay. So, what I would do on this is I would show to start with what I'm going to use the x as 0.78787878, etc. That is what the recurrence actually shows. If I'm using algebra for this one, I'm going to go and show that 100x, the reason I've chosen 100, I didn't use 10, I need to get the 7 and the 8 both to the other side of my decimal place. Had I had just one number recurring here, I'd have used 10. I've got 2 numbers, I'm using 100. Had I had 3 numbers, I'd have used 1,000, etc., etc. So I'll now have 78.78787878. You get the idea, okay? I've now got anything after the decimal point. These are all lined up now, okay? So if I was to do the 100x, subtract the 1x, I will be left with only 99x. And if I do 78.787878, subtract 0.787878, I'll just be left with 78, because all those that are after the decimal place, they're identical, they will cancel out. So I've got 99x equals 78. I'm wanting it as a fraction. Well, simply, I'm wanting to show what 1x is worth. Instead of a decimal, I'm wanting to show it as a fraction. Divide through by 99. That might be in this case. It could simplify. Well, why not check it out on your calculator? 78 over 99. Does it simplify? It does. It goes down. Both numbers divided by 3 brings us to 26 over 33. Okay. That method will work is if you are using x as whatever your recurrence is, then try to make sure you're always getting the parts that are after the decimal point lined up. It might be you need to go to a 10x and a 100x and then simplify so you get a 90x. Just look at the question carefully. Make sure that whatever's after the decimal point is lined up so you can subtract and get rid of those. Okay, I'll do one more before I switch back over to Mr. Sanders. Right, shown is a sector of a circle. We are told an angle and we are told a radius. So we are asked to calculate the length of the arc. Okay, so first of all, identifying where that arc is. Well, your arc, it's a part of a circle around its edge. Arc, like arch. If you think of an arch, if you go through an arch, you're going through something that's circular at the top. So I'm just wanting part of this arc. Well, that arc is made up from the circumference of the full circle. So if I'm wanting to work out the circumference of a circle, we should know that pi r squared sounds like area to me. If you need circumference, then use pi d. Yes, I did just say that. So if I'm wanting the diameter, I've been given a radius of 12. So therefore, if I've got a radius of 12, I've got a diameter twice that of 24. Okay, so the circumference of the full circle will be pi multiplied by 24. It's a calculator question after all. 24 multiplied by pi, we know will show on a calculator as 20. Etc. That would be fantastic if we wanted all the way around, but we don't. We only want 60 degrees of that full circle. Well, 60 out of my full circle of 360 cancels down to just 1/6. Or if it was a different number, tell you what, in case it's a tricky number, I'm just going to leave it as 360. So 60 over 360. I will take my 75.3982 and I'm going to leave it over 360. So had that been a nasty number, say, I don't know, 37 is prime, it won't make it any easier. So I would have had 37 over 360. I hit equals and it tells me, in this case, 12.56637 centimetres. It makes sense to round it to 2 decimal places is the general if you are not told otherwise. So therefore it goes to 12.57 centimetres. Okay, so you taking back over for a second? Yes, sir.
I have it now.
Do you want one?
No, I'm okay. Okay then guys, so I'm just going to take over a few more here. Now the first topic I'm going to look at is something to do with this. Now this is new to GCSE. If you're in my group, we'd have seen it when we watched that lovely video about guessing number of balls and the number of taxis in London. Okay, so it says a scientist wants to estimate the number of fish in a 30 fish from the canal. He marks each fish with a die and then puts them back in the canal. Next day, the scientist catches 20 fish from the canal. He finds that 4 of them are marked with a die. Part A, estimate the total number of fish in the canal. Now, this is all about equivalent fractions. So I'm just going to go through each bit again and do it a bit at a time. So, firstly,
write out the numbers that are essential, so it's coming out really pixelated on this.
Okay, so we've got 30 fish the first day. And we don't know the total. And on the second day, he catches 20 fish. And 4 are marked. Okay, so 30 fish, 20 fish, and 4. Okay, so this is all just a case of equivalent fractions. So at the beginning, we collected 30, and we didn't know how many there were overall. So I'm going to put that 30 out of something. The next day, we collected 20, but 4 of them were marked. So we know that 4 out of the 20 were marked. Okay, so now I know, because of the way this experiment works, we assume that these are equivalent fractions. So I need to work out what my missing number is. 2 ways to do that. We can see how to go from 4 to 30. So remember, it is a calculator paper. If you put in 30 divided by 4, it will give us 7.5. So you can multiply that by 7.5. So you'd have to do the same to the bottom. Or you can have a look at, well, how do we get from 4 to 20? We multiply by 5. So we're going to do the same over that side. So 30 times 5 is 150. Either way you did it, we'll give you the answer, 150. So we are estimating that there are 150 fish in that canal. Now, part B then, they like to throw this up. Write down any assumptions you have made. So there are 2 that we can do for all these. First, we need to assume that they are random samples. They need to be completely random, otherwise this will not give an accurate estimation. Number 2, we need to assume that the population does not change. Okay, so we are assuming that the population in the canal is the same on the first time as it is the second time. Okay, if it's not, once again, that will skew our estimate. Okay, next then. This will come up either on paper 2 or paper 3, so it's worth knowing. And that is histograms. How can we see that, sir?
Not very well. It's coming through really poor quality at the moment. We're having a couple of comments. Is there any bigger text questions that we've got?
We'll save those.
Should we go for a simultaneous equations? Or there's a quadratic simultaneous.
Go for it.
Have you got? Do you want a whiteboard pen so it just comes out that bit thicker?
Yeah, can do. So, says solve the simultaneous equations, then x squared plus y squared equals 25, and y minus 2x equals 5. Now, this is higher only. Okay, we can't do this like we would a normal simultaneous equation because we can't eliminate one of those. So what we're going to do is rearrange that to make it either y equals or x equals. And now this one is a lot easier because we've already got a y on its own. We're going to rearrange it to y equals, and then we're going to add 2x to both sides. So it would be y equals 2x plus 5. Now I know that what y is, I can substitute that straight into that equation. So every time I see a y, instead of putting y, I'm going to put 2x plus 5 in brackets. So I'm going to have x squared plus, and now instead of y, I've got 2x plus 5, and that is squared, and that equals 25. So if I wrote that out in full then, that would be x squared plus 2x plus 5 times 2x plus 5 equals 25. So just like Mr. Russell did a few minutes ago, I'm going to expand those brackets. So 2x times 2x is 4x squared, Mr. Russell. 2x times 5 is plus 10x. 2x times 5 is plus 10x. And 5 times 5 is plus 25. So I've still got my x squared there, and I've still got my equals 25 there. I'm now going to start making this a little bit tidier. So I've got two lots of 10x there, so I'm going to simplify that to 20x. I've got an x squared and a plus 4x squared there, so I've got a 5x squared. So 5x squared plus 20x plus 25 equals 25. I'm just going to get another piece of paper to draw on the back of. So once again now, just like before, I've got a quadratic equation. Now in order to solve that, I need to leave it equal to 0. So I need to get rid of that 25, and I'm going to subtract 25 from both sides. So that will leave me with 5x squared plus 20x. 25 take away 25 is just 0. So that equals 0. Okay, now, well, I'm looking at this now, and I need to be able to solve it, need to work out what x is. Now, I can do something to make this a little easier. Both of these terms here are divisible by 5, so I'm going to divide everything by 5. So I've got x squared plus 4x equals 0. Okay, now I need to solve that. So in order to do that, I'm going to need to factorise this. So I'm going to say, is there a term that goes into both of those? Yes, they've got an x in both. So I've got x brackets, x times x is x squared, x times 4 is 4x, and that is still equal to 0. Now, in order for this to work, one of these, either the x or the x plus 4, has to be equal to 0. So they're going to have two answers. We're going to either have x equals 0 or x plus 4 equals 0. So x would equal negative 4. So they're my two values for x. We're not quite there yet. Am I still on the screen, sir?
Yeah.
Okay, so now then I'm going to substitute these two values back into my original equation one at a time. Okay, which one should I substitute into, sir?
First.
Yeah, okay, so we're going to substitute both of those into my first equation. So just a reminder, if you can't see at the top there, the first equation was x squared plus y squared equals 25. So if x equals 0, then 0 squared plus y squared equals 25. Well, 0 squared is just 0. So y squared equals 25. So y equals 5. So when x equals 0, y equals 5.
And it works for the next one, the other equation as well, doesn't it?
It does, yeah. And for the next one then, substitute x in. So we could have negative 4 squared plus y squared equals 25. So negative 4 squared is 16 plus y squared equals 25. So y squared equals 25. Take away 16, which is 9. So y equals 3.
okay there?
Is that correct?
Not being followed.
I'll double check those ones.
Okay. The quality is in and out, some are commenting, so probably stay away from the graphs if you can. Is that one?
One last iteration.
Do you want
To finish off one.
Yeah, we've got time.
You go for this one?
We could start late anyway.
This is one that people have been requesting for ages, so hopefully you can see this. This is another new topic. It is iteration, and this normally comes in 3 parts. Part 1, up here, it is a show that it has solutions between. Part 2 is a show that a rearranging, and part 3 is the actual iteration. So firstly, we need to find that this has solutions between x equals 0 and x equals 1. So to do that, I'm just going to substitute both of those into it. So firstly, I'm going to do 1 cubed plus 4 lots of 1 equals, and then I'm going to work out what that is. So 1 cubed is 1 plus 4, and that equals 5. Next then, I'm going to substitute in x equals 0. I don't know why I did it that way around. So 0 cubed plus 4 lots of 0. So 0 cubed is 0 plus 4 lots of 0 is 0. So that is 0. Now we can see with our answers, we got one of them is 5, one of them is 0. Okay, what we wanted to get was 1. Okay, so one answer is greater than 1, the other answer is less than 1, so the real solution must be somewhere in between. So, sorry, 1 is greater than 1, 1 is less than 1, so the real solution is somewhere in between. Next then, show that the equation x cubed plus 4x equals 1 can be rearranged to give this here. So there are several different ways of rearranging these equations to give these. So let's have a look at the clues we're given. Now, we've still got an x cubed there. So we're going to try and get the x cubed on the other side of the equation. So to do that, I'm just going to take it away from both sides. So I'm just going to do this on a plain bit of paper underneath. So we've got x cubed plus 4x equals 1. So I'm going to take away x cubed from both sides. So that would give you 4x equals 1 subtract x cubed. Well, now I need to divide it by 4. Divide it by 4. So x equals 1 minus x cubed divided by 4. Now I'm looking at that and I'm thinking that doesn't quite look like the question they've given me there. Well, actually, it's exactly the same thing, because remember, when we subtract fractions, if the bottom number is the same, then they can just be combined together. So we can then just put underneath, you don't need to show any more work in, x equals 1 over 4 subtract x cubed over 4. And that is plenty to show it. Okay, the final bit then, the actual iteration of that. So it tells us that x0 equals 0. Use the iteration formula, xn plus 1 equals 1 over 4 minus xn cubed over 4 twice to find an estimate for the solution of x cubed plus 4x equals 1. So first thing I'm going to do is I'm going to write down what my x0 is. So x0 equals 0. Now the way that these iteration formula work is the next answer I get will be x1. So to do x1, I'm just going to use this equation here, but every time I see an x, I'm just going to use my previous answer. So it's going to be 1 over 4, take away, xm was 0, so 0 cubed over 4. Remember, it is a calculator paper, put it in your calculator. So we've got 1 over 4, subtract 0 cubed over 4, and that will tell me that is 1/4, or if you want to put it as a decimal, is 0.25. Now then, I'm going to do my x2, and that equals the same thing again, 1/4, take away, but this time, instead of using 0, I'm going to use 0.25 cubed over 4. So I'm just going to go back, and in my calculator, neat trick here, I'm going to get rid of that 0 that I did last time and just use the A and S button. And that will use my last answer. I'm just going to press that. So that tells me I've got 0.2460935. Now because that answer button's been put in, the calculator will do everything else for us. So if I just press equals again, it will tell me that x3 equals 0.24627400093, and now you need to do that for it just said twice actually, so I've done one too many, so that x2 is enough to finish on there. Okay, so that would be your final answer there. Anything else, sir?
Yes, we've got a request for nth term quadratic.
Have you got
We've got split between those that like your way, those that like my way, so we thought we could do maybe
One
same
each?
question both.
Okay, yeah.
Same question both ways. Do you want to start off with your way?
I'll start my way.
You got your audience.
Okay, so here are the first 5 terms of a quadratic sequence. I'm glad Mr. Russell stepped in to do it his way because I don't know that. So first thing I'm going to do here then, I'm going to...
Seems to have a problem with the feed. Are we live again? Someone comment say we're live, please.
Looks like we are.
Yeah, back.
You're back?
All right, so start that question from scratch. I'm not sure where it paused.
Okay, so we're going to do this in 2 different ways. We're going to do the same question, but twice. So I'm going to leave it there. I'm going to get another piece of paper so I don't ruin it for Mr. Russell. Okay, and I'm going to find the nth term of this quadratic sequence. So if I just write it out again, that one you can see right through. Have you got any?
I've got some blank ones over here. We'll finish with.
Should be fine. Okay, so we've got 9, 17, 29, 45, and 65. First thing, I'm going to find a difference between each of those. So I've got 9 to 17 is 8. 17 to 29 is 12. 29 to 45. So taking my calculator away.
Sorry.
I
didn't take that one.
I'm going to double check just because I don't want to make any silly mistake. Is 16. And then obviously the last is 20. Now, if that was the same there each time, this would be a linear sequence. It tells you it's quadratic, so we know it's not going to be the same. So we're going to find the second difference this time. So 8 to 12 is 4. 12 to 16 is also 4. 16 to 20 is also 4. So this is the part that most people forget if they're going to forget anything. Whatever we get here, we need to half, and that will tell us what square numbers it is. So half of 4 is 2, so this will be a 2n squared sequence. So I'm going to write the sequence out again underneath. And underneath that, I'm going to write out what the 2n squared sequence actually is. So in the bottom corner here, just to help me out, I'm going to write the square numbers. So I've got 1, 4, 9, 16, 25. So the 2n squareds are just going to be 2 lots of those. So instead of having 1, it'll be 2. Instead of 4, it'll be 8. Instead of 9, it'll be 18. Instead of 16, it'll be 32. Instead of 25, it will be 50. So this was my 2n squared. This was my original sequence. So I need to see how do I get from 2n squared to my original sequence. Okay, so I need to add 7 for that one. I need to add 9 for that one. I need to add 11 for that one. I need to add 13 for that one and add 15 for that one. So I know my final sequence will be 2n squared and then something. Well, if you notice now, this is just a normal nth term, the type you'll have been doing way back when you first started sequences. So we need to find out what that is. Now, that goes up by 2 each time. So that's like it's the 2 times table. So that will be 2n. Well, the 2 times table starts with a 2. So how do I get from the 2 times table to that? I need to add 5 on. So finally, our total sequence then would be 2n squared plus 2n plus 5. Now, I know some of you prefer Mr. Russell's way, so he's going to go and show you that one. Hopefully, we'll get the same answer.
Yeah. Apologies, guys, for the interference. It was due to the battery warning on the iPad, but we'll go until the battery dies, if you're happy to say. Mm-hmm. And for whoever was talking about Love Island, you're now blocked for the next 6 minutes, so you can focus on the maths for a while.
Right. My way, it's using some algebra. So it's a case of the parts that you can remember. There are 3 parts that you need to know. First of all, it's knowing that the first term is made up of A plus B plus C. The next part, it's knowing that the first difference, so this is our first term, we need to know that the first difference is 3a plus b. That's the first diff. And that our second difference is equal to 2a. Now that second difference in 2a is very similar to Mr. Sanders' way of knowing that he has to half when he gets down to the bottom. Oh, do I need to, is that better?
Yeah.
Yep, okay. So if I start by actually looking for my differences, as Sir did, 9, 17, 29, 45, that should be enough. I've got a gap there of, well, let's have a look. We've got 8, a gap between 17 and 29 of 12, and a gap between 29 and 45 of 16. The gaps here, thankfully, they are consistent. And the fact that I've got 2 the same means I know it is a quadratic. After all, it did say in the question. Now, applying the parts that we know, if I use some colours to help, 4 is equal to this 2a. So if I know that 2a equals 4, I know that a is equal to 2. Okay, I'm now going to use that on the next part. If my first difference, as I mentioned earlier, was 3a plus b. So I now can say that 3a plus b equals 8. So 3 lots of a that I've just found will give me 6 plus b equals 8. Therefore, b, or 6 plus something equaling 8, b must be 2. And then using the first fact that I gave you, a plus b plus c being your first term, we now know that a plus b plus c equals 9. Well, we've got a as 2, we've got b as 2, 2, plus c equals 9. Well, I've got 4 plus c equals 9, therefore c must be 5. Writing that as the quadratic formula, and the colour I've not used yet, I'll go for green, would be in the form of an squared plus bn plus c. Well, that will give me 2n squared plus 2n plus 5. 2, 2, 5, 2n squared, 2n plus 5. Okay, if you've got no idea what the a plus b plus c, the 3a plus b, and the 2a, pardon? We're frozen again. Down to, whereabouts did we get to?
I think it's the answer.
Right. Sorry guys, we're down to 5%. We'll go until that battery goes. If you're not sure where the a plus b plus c, the 3a plus b and 2a come from, if that's completely new to you, use Mr. Sanders' method, because obviously that works for you. We're just going to go through some more until it goes. So if it freezes, please let me know, then Mr. Sanders can just press the button on the top. I'm going to go for some surds. Sure, that's what it is there simplifies to what this is. I'm going to go rather quick. Remember, when you watch it back, you can pause. So what we're wanting to do here, well, I'm looking at that top line and I'm thinking I'm going to expand that top line. So as I was doing last time, 4 and 4 make 16. 4 and root 3 give me 4 root 3. A negative root 3 and a 4 give me a negative 4 root 3. That's very convenient. Thank you, question. And the part that most people make a mistake on, I've got negative root 3 multiplied by positive root 3. Well, negative root 3 plus multiplied by positive root 3 will give me a negative root 9. Well, I know the square root of 9 is just 3, so I'll be subtracting 3, okay? Divided by root 13. If I simplify my top, thankfully my root parts, they are going to disappear. So I've got 16 subtract 3. I've got 13 over root 13. Looking a lot more like just root 13 and a lot easier than it was to start with, but we're not quite there yet. To rationalise denominators, i.e. to get rid of a square root on the bottom, we must multiply by the equivalent of 1. Well, I can write 1 as anything divided by itself. In this case, I'm going to do it as root 13 over root 13, because root 13 multiplied by root 13, as previously mentioned, will make it so I just have a 13, and 13 multiplied by root 13 is 13 root 13. Well, I've now got 13 on the outside, on the top, and on the bottom, so they cancel out, leaving me with just a root 13. Abracadabra. What we got next? We've got another rationalised. I'll
skip that one and go on to this one. We've got some bounds, a bound question. They tend to be towards the back. We've got a division. We've got d, which is equal to x divided by y, and I'm wanting my upper bound for d. Well, to look at that, if I'm wanting the biggest possible number for d, I'm wanting my maximum possible answer for x, and I'm wanting to share it between my minimum possible answers for y. Okay? So think, to get d as big as possible, I need to have as much as possible to start with and share it out between the fewest. If I wanted my answer for whichever I'm trying to find, in this case, if it's these, I want it to be small, I want to start with a small amount and share it out among as many as possible. So if I now look at x 99.7, correct to 1 decimal place. So 99.7, like last time when I was doing that number line, I could have had a 99.6, I could have had a 99.8.
How are we doing?
So I'm wanting 99.75. That will be my upper bound here. My minimum for y, well, y was 67 to 2 significant figures. 68 is a 2 sig fig. 66 is a 2 sig fig. I'm wanting my minimum, so I've got to go here, 66.5. Sorry, I'm going quick. I'm doing it before the battery goes. So now, to use these two numbers, I'm wanting to work out d. It was a max of x, which was 99.75, divided by my min for y, which was 66.5, gives me an answer, very conveniently, of 1.5. Just so you can see what I typed in, 99.75 divided by 66.5 there gives me an answer, upper bound. The maximum it could have been was 1.5.
Are we doing all right?
Brilliant. Okay, we've got a diagram of circle, centre. Oh, this may well be our last question. If we don't get to say good luck, good luck. The circumference of the circle is 20 pi centimetres. Find the equation of the circle. Crikey, we're finishing with the hard ones now. So, I'm thinking circumference. Well, as I sang at you earlier, circumference equals pi d. Well, if I know that the circumference is 20 pi, that equals pi d. So if I get rid of that, it tells me that my diameter, therefore, must have been 20 centimetres. Well, if I'm wanting the equation of a circle, the general equation for a circle that's on the centre 0 is x squared plus y squared equals r squared. Well, if I know my diameter all the way across is 20, I therefore know that my radius would be 10. So I can say that the equation of my circle is x squared plus y squared equals 10 squared. I can write that, if I want, as x squared plus y squared equals 100. I found the equation of the circle right here. That is your very generalistic equation for a circle. You may also be given a slightly tricky one, that's x minus a